Right. So, are you able to see the screen? Yes. So the screen is visible or not? Okay.
Visible.
Yes,
Visible.
yes. Okay, fine. So, right. So, as discussed earlier, redox reactions. So, the reactions which is involved, both oxidation and reductions are called redox reactions. So, the oxidation means simply loss of electrons, reduction means gain of electrons. So, then one of the best example for the redox reaction, that is the Daniell cell. Then in Daniell cell, at anode, oxidation will take place, that zinc gives rise to Zn plus 2 electrons. So then at cathode, reduction will take place, that 2 electrons are gained by the copper, then converted to the copper plus 2 is converted to the copper. So then one more EMF, that is the electromotive force, that is the potential that can be determined with the help of this following equation. So that is Zn by Zn plus 2 double vertical line copper plus 2 by copper. Then the EMF is equals to reduction, standard reduction potential of cathode minus standard reduction potential of anode. Or else if one is having oxidation potential, other is having reduction potential, at that time we have to use summation, right? So the Daniell cell is the example of zinc copper electrode, that will be 1.1 electron volts already completed. Then the derivation of Nernst equation. The reduction potential of single electrode, that can be determined with the help of Nernst equation, right? So then the electrode potential, that should be depends on various parameters like, so the parameters are like, just wait, right. So the parameters are like single electrode potential, that can be depends on nature of the various constituents employed, then temperature and activity of the reactants and products. These are the three parameters. The electrode reduction potential is depends on these three parameters, like nature of the constituents implied in that particular equation, temperature and activity of reactants and products. So then, so by considering one general equation, that is A plus B is gives rise to C plus D, then one of the thermodynamic parameter change that we can consider delta G is equals to delta G naught plus RT, ln activity of products by activity of reactants. And also we know the relation between delta G and E cell, that is delta G is equals to minus NF E cell, and delta G naught is equals to minus NF E naught cell. Now substitute these two values in our equation and simplify, we will get the Nernst equation. So that is E cell is equals to E naught cell minus RT by NF ln activity of the products. These are divided by activity of the reactants. So then the ln can be replaced with the logarithm. So that is ln can be replaced with logarithm, that is multiplied with 2.303 log. A is equals to E naught minus 2.303 RT by NF log activity of products by activity of reactants. So here E cell is the EMF of the cell or potential of the cell, and which can be utilizes to get the potential of various type of the cells. So this was already completed in the morning session, right? So then electrochemical cells, that are chemical cells and concentration cells. The chemical cells are again classified into two types, without transference and with transference. Then concentration cells are two types, electrodic concentration cell and electrolytic concentration cells. So these electrodic concentration cells are gas and glass electrodes, electrolytic again without and with transference. So what are the chemical cells means? The EMF, the potential will be developed, right? The potential will be developed, that is due to the chemical reactions. Due to the chemical reactions, whether the oxidation and reductions will be takes place, with respect to that, the chemical potential will be developed. So that we are going to find out in chemical cells. Then another concentration cells will be there. The EMF is developed due to the transfer of substance or any ionic species. So means some of the substance is transferred from high concentrated electrolyte solution to low concentrated electrolyte solution. High concentrated electrolyte solution to low concentrated electrolyte solution. So therefore the potential is developed. That developed potential will be considered as concentration potential. So then we discussing about without transference and with transference. What is the meaning of without transference? Means there is no direct transfer of electrolyte solution of any ionic species from one electrolyte solution to other electrolyte solution. So two electrolyte solutions will be there. The EMF will be developed, but there is no direct transfer of one electrolyte substance from one electrolyte to another electrolyte. That is without transference. A direct transfer from one electrolyte to other electrolyte. For example, cations are transferred or anions are transferred. So therefore, we can consider that is the direct transfer that becomes with transference. Therefore, with the help of this, now we are going to construct the chemical cells with transference and without transference, then concentration cells with transference and without transference. So first chemical cells without transference. Without transference means there is no direct transfer of any ionic species from one electrolyte to other electrolyte. Then chemical cell means the potential is developed. The potential is developed due to the chemical reactions. So due to some chemical reactions, the potential will be developed. So then there is no direct transfer of ionic species from one solution to other solution. At that time, we will get the EMF of chemical cells without transference, for which we need to select two electrodes and one electrolyte solution. That one electrolyte solution becomes HCl is an electrolyte solution. HCl may consisting H plus ions and Cl minus ions. One of the electrode that is reversible to the H plus ions, that is the hydrogen electrode. The another electrode is reversible to the anion, that is the chloride electrode. So we need to get the EMF of this chemical cells without transference. We must select two electrodes. We must select two electrodes. This is the one of the electrode, that is the hydrogen electrode, and this is the other electrode, that is the chloride electrode, and also one electrolyte solution, that is the HCl. So therefore, to construct the chemical cells without transference, we need to select two electrodes and one electrolyte solution must be selected. That electrolyte solution is the HCl, and the two electrodes are hydrogen electrode and chloride electrode. Therefore, each individual electrode potential can be getting by the application of Nernst equation, and the sum of the two electrodes gives the total EMF of the cell. That total EMF of the cell is nothing but chemical cells without transference. So that is E1 plus E2, in which we are discussing about the two electrodes, right? So one of the electrode is undergoing oxidation, that is hydrogen is undergoing oxidation because its reduction potential is less compared to the chloride electrode. So hydrogen is undergoing oxidation. That oxidation reaction is half H2, half H2 gives rise to H plus plus 2 electron. H plus plus electron. By applying Nernst equation, we'll get E1, that is E of H2 is equals to minus RT by NF ln activity of H plus. Similarly, whenever the hydrogen is losing electron, that electron is gained by the chlorine, right? So that means one of the electrode, that is the silver chloride electrode, right? So this is the silver chloride electrode. The silver chloride, by absorbing that particular electron which is obtained from the hydrogen electrode, so therefore it will be converted to the silver and Cl minus, not silver plus, only silver, right? So not silver plus, only silver plus Cl minus. Then applying Nernst equation to this, we will get V2 is equals to E naught of AgCl by Ag minus RT by F ln activity of Cl minus. Therefore, E1 will be there and E2 will be there. Just we combined both E1 and E2, both E1 and E2, we will get the overall EMF of this cell. That is the one method. One method means by combining of E1 and E2 will get overall cell EMF. The another method will be there by considering the overall cell reaction. So this is the overall cell reaction, that is half H2 gas atmosphere plus silver chloride gives rise to silver plus HCl, A1 activity of HCl. So the Nernst equation is applied to this. Nernst equation is applied to this overall equation. So therefore, we can get the EMF of chemical cells without transference, right? So then, by applying Nernst equation, we can get this final equation, that is E cell is equals to E naught of AgCl by Ag minus RT by F ln activity of HCl. A1 of HCl means that is activity of HCl. E naught of silver chloride is known. By combining of hydrogen and silver, we'll get E cell. Then R is the gas constant, T is the temperature, and F is the number of Faradays. These all values means these values already known because standard values. So this is obtained from the construction combining of hydrogen electrode with a silver chloride electrode. Therefore, with the help of this E cell, the activity of the HCl can be determined. That is the useful of chemical cells without transference. When we perform the reaction of chemical cells without transference, so which electrolyte solution we are using, we can get the activity of that electrolyte solution with the help of performing of this procedure, right? So the morning session already we covered up to here. So then after that, one more will be there. That is the chemical cells with transference, right? So is it clear? So that morning session topic I covered again, right? So then we'll continue with the next topic. So that is the chemical cells with transference. With the transference, simple meaning will be there. These are the two electrodes, left and right, two electrodes, right? Some of the ionic species are transferred from one electrolyte solution to other electrolyte solution directly. So that is nothing but with transference. With transference means a direct transfer of ionic species from one electrolyte to other electrolyte solution. Whenever a direct transfer of ionic species will be there, what will be the potential is developed. So that will be considered with the help of chemical reactions. Therefore, we can get the overall cell EMF of chemical cells with transference. Right. So anything, either chemical cells or concentration cells, how we are going to construct. So we need to select electrodes and electrolyte solutions. We have to select with the help of that electrodes and electrolytes, we will get the overall EMF of that particular cells, right? So without transference is completed. Now with transference, so we'll see to construct the chemical cells with transference. two electrodes and two electrolyte solutions must be selected. How many electrodes? Two electrodes. How many electrolyte solutions? Two electrolyte solutions. But in case of chemical cells without transference, two electrodes and one electrolyte solution. But here two electrodes and two electrolyte solutions. Individual electrode and individual electrolyte solutions must be selected. With the help of that, a direct transfer of ionic species from one solution to other solution, at that time what will be the developed potential that we will derive. Okay, are you understand the concept? What we are going to derive with the help of Nernst equation. Yes. Are you approaching my class? Right. So be patient and be concentrate. So don't be neglect, right? So try to understand the language and try to get the information, right? Try to understand the concept. Okay, right. So what was that concept, right? So what was that concept means? Application of Nernst equation. Then how many electrodes, how many electrolytes are considering? That depends on our question. That is chemical cells with transference. Two electrodes and two electrolyte solutions must be selected. So therefore, the EMF is developed due to the transfer of ionic species from one electrolyte solution to other electrolyte solution. Example, see here, one of the electrode, that is the zinc electrode, that is dipped in zinc sulfate solution. The another electrode is copper electrode that will be dipped in copper sulfate solution. The two solutions are, one is the zinc sulfate and copper sulfate. The zinc rod is dipped in zinc sulfate solution and the copper rod is dipped in copper sulfate solution. These two solutions are also connected with the salt bridge, right? Why we are using salt bridge? What is the help of the salt bridge? We'll see, right? So just see here the construction of this. This is the partition of these two compartments. This is the partition of two compartments, right? So in one compartment, that is the zinc sulfate solution will be there. This is the zinc sulfate. In another compartment, copper sulfate will be there. Then the copper rod is dipped in copper sulfate and the zinc rod is dipped in zinc sulfate solution. Then these two electrodes are connected with the external battery. And also as well as salt bridge, right? This is the salt bridge. This is the U shape, that is the salt bridge, right? So whenever this experimental setup will be done, the two electrodes we are utilizing, one is the zinc and other is the copper. So whose standard reduction potentials are known? That is, copper reduction potential is more compared to the zinc. Therefore, copper itself acts as cathode. At cathode, reduction will take place. Then zinc itself acts as anode. At anode, oxidation takes place. Due to oxidation and reductions, we'll get the redox reaction. Therefore, after getting redox reaction by applying Nernst equation, we can get the solution of our concentration cells with transference. Right? So this is the junction, right? So this is not function, this is the junction, right? So this is the junction that will be denoted with J. The ionic species which will be transferred from one solution to another solution across the junction. Across the junction. So our heading was direct transfer of ionic species from one electrolyte to another electrolyte. So that direct transfer is the electrons are transferred from zinc to copper. The electrons are transferred from zinc to copper. Therefore, the overall EMF of the cell can be written as E cell is equals to E1 plus E2 plus EJ. This E1 is applicable for zinc electrode, E2 is applicable for copper electrode, and EJ is applicable for the junction. Whenever some of the ionic species is transferred from one electrolyte to other electrolyte across the junction, the potential is developed at the junction, right? So for example, here the electron which is moving from zinc to copper, the positive charges will be deposited here at the junction. So whenever the positive will be deposited, simultaneously the negative also will be deposited here. Therefore, this is the potential which will be developed at the junction. Whatever the potential will be developed at the junction, that can be eliminated with the help of using salt bridge, right? So by using salt bridge, so what is the salt bridge means? So which consisting the KCl or ammonium nitrate solution with the help of salt bridge, the liquid junction potential, the junction potentials becomes neglected. How it becomes neglected? So that salt bridge will be consisting K plus and Cl minus ions. K plus and Cl minus ions. So what is the K plus and what is the Cl minus means? This is the positive ion and this is the negative ion. For example, zinc is converted to the Zn plus 2. Zinc is converted to the Zn plus 2 by loss of 2 electrons. That 2 electrons are transferred from zinc solution to copper solution. So means Zn plus 2 will be there, that will be deposited here. Then to neutralize that ionic charge, the Cl minus in the salt bridge that will go and react with Zn plus 2. Therefore, that forms ZnCl2. Therefore, the charge will be neutralized. Like that, any negative charge will be found at the junction. The K plus ions will move and neutralize them. Therefore, the potential will be zero at the junction. With the help of salt bridge, we can neglect the liquid junction potential. We can neglect the liquid junction potential, right? Are you understand? Yes, right. So the easy is the liquid junction potential, right? So this liquid junction potential can be eliminated using salt bridge. The salt bridge will be prepared with electrolyte solutions like KCl and ammonium nitrate with agar-agar salt. Therefore, EJ will be 0. Why these specific ions KCl and ammonium nitrate means the transport numbers are same. The cation transport number and anion transport number will be same. So due to that cation and anion transport numbers, right? So immediately they will go and neutralize the ions, either cations or anions, whatever it. Okay. So that's why the ions which are having same transport number, that will be filled in the salt bridge, right? So this is the concept of salt bridge LJP. We will discuss again in detail in the next classes, right? So then now EJ will be 0. Then two electrodes will be there. One is the zinc, other is the copper, right? So we told that the reduction potential of zinc will be more. The reduction potential of zinc will be more. So the reduction potential of reduction potential of copper will be more. When the copper reduction potential is more, therefore it is always involved in reduction. So the automatically zinc is involved in oxidations. Therefore, the zinc is undergoing oxidation means this is the oxidation reaction. Simple oxidation means you have to remember gaining loss of electrons. Oxidation means loss of electrons. The zinc will be converted to the Zn plus 2 electrons. So then apply the Nernst equation. E cell is equals to E naught cell minus RT by 2F ln activity of the product, that is the activity of Zn plus 2 by activity of the reactant. This reactant zinc is the solid, therefore solid's activity is 1. So therefore we can get E of Zn plus 2, Zn by Zn plus 2 is equals to E naught of Zn by Zn plus 2 minus 40 by 2 means 2 electrons are varying, that is the N is the 2, then Ln activity of Zn plus 2. Similarly, the copper is undergoing reduction. So the representation of that reduction reaction was copper plus 2 electrons are gives rise to copper. Means those two electrons are gained by the copper, So therefore, copper plus 2 ions will be converted to copper plus 2 ions will be converted to the copper, right? So then now apply the Nernst equation. Now apply the Nernst equation, that is E of copper plus 2 by copper is equals to E naught. Means E cell is equals to E naught cell. E cell is equals to E naught cell minus RT by 2F ln activity of copper by activity of copper plus 2. Activity of copper is the solid, therefore activity is 1. Copper plus 2 is the ion, its activity should be there, right? So therefore we'll get this equation. The overall cell reaction, whenever zinc is undergoing oxidation, this is the oxidation, zinc, then copper is undergoing reduction, that is copper plus 2 is converted to the copper. So this is the overall cell reaction. One is called oxidation, the other is called reduction. So therefore, both oxidation and reductions takes place in a single reaction that becomes the redox reaction. Therefore, now apply the Nernst equation to this redox reaction. E cell is equals to E naught cell minus RT by 2F ln. Activity of the products. Products means ions only consider, that is Zn plus 2 by activity of copper plus 2. So this is the equation represents the chemical cells with transference, right? So as is it clear? Yes, Esma, you have to respond. Is it clear or not? Right. So what we are going to do, so just I will explain in on our mother tongue language. Simple. 2 electrodes తీసుకోవాలి, 2 electrolyte solutions. 2 electrolyte solutions first ఏంటి? జింక్ సల్ఫేట్, కాపర్ సల్ఫేట్. జింక్ సల్ఫేట్ లో జింక్ రాడ్, కాపర్ సల్ఫేట్ లో కాపర్ రాడ్, then connected to the external battery. So both beakers are connected with salt bridge as well as. Salt bridge ఏంటంటే జంక్షన్ లో డెవలప్ అయిన పొటెన్షియల్ ని ఎలిమినేట్ చేయడానికి యూజ్ చేస్తాం, రైట్? సో 2 electrodes కనెక్ట్ చేసినాం కాబట్టి 1 electrode undergo oxidation, the other is undergo reduction. Oxidation reaction ఏంటి? Zn gives less to Zn plus 2 plus 2 electrons. జింక్ అనేది 2 electrons లాస్ అవుతుంది. సో దానికి Nernst equation అప్లై చేస్తాం, విల్ గెట్ E1. Then the 2 electrons are gained by the copper plus 2 ions. Copper plus 2 electrons gives rise to the copper. So that is the reduction. Apply the Nernst equation, will get E2. The sum of these two, that will give overall EMF. Or we'll consider the overall cell reaction, that is E cell is equals to E naught cell minus RT by, overall cell reaction, zinc plus copper plus 2 gives rise to Zn plus 2 plus copper. By applying Nernst equation, we will get E cell is equals to E naught cell minus RT by 2F ln activity of Zn plus 2 by activity of copper plus 2. Activity of copper plus 2, right? So as we know that activity, the concept of activity, so that we'll discuss it in the thermodynamics. Simple, activity is applicable for the non-ideal solutions. If it is a ideal, directly we should consider the concentration. If it is a non-ideal, we can consider the activity. So the activity is equals to activity coefficient multiplied with concentration, that is the molarity. మనం యూజ్ చేసే సొల్యూషన్ ఐడియల్ సొల్యూషన్ అయితేనేమో డైరెక్ట్లీ we can consider the concentration. If it is a non-ideal solution, right? So we can consider the activity. So that is activity coefficient multiplied with the molarity. So that activity A is equals to gamma into M. This should be applied for individual ions, A of Zn plus 2, A of copper plus 2. That means gamma of Zn plus 2 into M of Zn plus 2. This is the M molarity. M of Zn plus 2. A of copper plus 2 is equals to gamma of copper plus 2 into, not plus, into M of copper plus 2. These values are substituted in the above equation. We can get one more equation. One more equation. So what was that equation? Means this below equation. E cell is equals to E naught cell minus RT by 2F ln M of Zn plus 2 into gamma of Zn plus 2 by M of copper plus 2 into gamma of copper plus 2. Gamma of copper plus 2. So therefore we can separate this M term and gamma term. This is in the form of ln A into B formula. Therefore ln A minus ln B formula. Sorry, ln A plus ln B formula. Here minus will be there. That's why minus applicable for both the terms. Therefore E cell is equals to E naught cell minus RT by 2F ln M of Zn plus 2 by M of copper plus 2. These represent the concentration ratio minus RT ln gamma of Zn plus 2 by gamma of copper plus 2. So once we construct E naught, it means standard one, reference one, it will be known. R is the gas constant known, T is the temperature is known, F is the number of Faradays are known, 96,500 coulombs, right? Then concentration of the electrolyte solutions also known, which concentration we are utilizing, zinc sulfate and copper sulfate. Whenever these two are combined, zinc and copper are combined together, so we'll get a E cell. Therefore, finally we can calculate this gamma of Zn plus 2 by gamma of copper plus 2. That means we can state that the ratio of activity coefficients can be determined with the help of chemical cells with transference equation, right? So that is the thing here. The ratio of activity coefficient of an electrolyte can be determined by substituting the values of E cell, E naught cell, and ratio of concentration of electrolyte solutions in the above equation. The overall conclusion with these chemical cells with transference, the activity coefficients ratio can be determined. What your ratio ni determine chestam. So that is the useful of construction of chemical cells with transference. Without transference వల్ల ఏం చేస్తున్నాం? Only activity we are going to find out, because only one electrolyte will be there. That electrolyte activity can be determined with the help of chemical cells without transference. But chemical cells with transference will be there. Two electrolytes we are utilizing. The activity coefficients of the two electrolyte solutions can be determined. These are the two conclusions of chemical cells without transference and chemical cells with transference. Is it clear? If you understand this, then I can move to next one. Right? So anyone unmute yourself and just interact. So because are you approaching class? Yes.
Sir, good evening.
Yes, good evening.
Sir, what do you mean by, sir, activity of that cell?
Activity. Right. So whether ideal solution will be there, directly we can consider the concentration. But non-ideal solutions means that are deviating from the Raoult's law, that are deviating from the ideal behavior. So for such solutions, we have to consider the activity. Activity is nothing but concentration only.
Concentration of solutions, sir.
Yeah, concentration of non-ideal solutions.
Non-ideal solution.
Yeah.
And in case of ideal solutions, sir?
Directly concentration we can use.
Oh, right.
Okay. Anything else? Even other members. Even if you want, I can explain in our mother tongue also, don't worry. So you have to understand the concept,
Sir,
right? Ah.
sir, one request, sir. Can you explain one with example, sir? With E cell is equal to E0 cell minus RT by 2F log MZN plus 2 by like that, sorry.
Okay, this one I can explain with the help of one equation.
Yes.
Okay, example. Okay, I can explain. Okay. Right. So first this is concept will be completed because one more another two will be there. Concentration cells without transference, then concentration cells with transference. Similarity will be there. After completion of that, I can give the examples of all four at a time.
Right, sir.
Like chemical cells without transference, chemical cells with transference, concentration cells without transference, then concentration cells with transference. Okay. Out of these four questions, definitely one question will come in the examination.
Yeah.
So most similarities will be there. Just you have to understand the concept. With the help of that, go ahead, right? Simply you can write the equations. Once you know the concept, so how we are going to approach? Only one
Sir,
simple concept will be there.
this formula is a standard, sir.
Yeah, Nernst equation is the standard one.
Oh.
The entire concept will explained with the help of Nernst equation only. You have to practice the Nernst equation. Any reaction will be there. Either oxidation or reduction will be there. How we have to write the Nernst equation means how we have to apply the Nernst equation to that particular equation. Either it may be either oxidation or reduction or redox reaction. Any reaction will be there. How the Nernst equation is applied to that equation. Why we are going to apply the Nernst equation to that reaction means we have to know the potential of that reaction. That is the advantage.
Sir, numerical questions may also come, sir, on that.
Yeah. Based on this, numerical problems also will come.
Oh,
But
sir, you will explain later on.
Yeah, after these remaining two topics, I can share the numerical problems, right?
Yes.
Or else I will give the question, you have to try. I will explain one example. The remaining three, I will give the question to you. You have to try. Whether you are
Right, sir.
getting trouble to solve those equations, I can explain later. Means
Okay.
in further class. Okay.
Yes, sir.
Right. Any queries are there, you have to raise your hand or you have to message. Because so in between now discussion means it will take time. So we have lack of time. So that's why just anything will be there. Just you have to raise your hand. So one raise your hand will be there. So or else you have to put one message, right? So I can see that message and I'll respond at that time. Or else after completion of the class, I can give 5 to 10 minutes. We will discuss based on that entire class. Okay.
Okay, sir.
Right. So now one more concept will be there. That is concentration cells without transference. Right. So concentration cells without transference. What are the concentration cells? Simple. First, we have to know the concentration cell, about the concentration cell, right? The potential is developed. The potential is developed due to the transfer of ionic species or any substance from one electrolyte solution to other electrolyte solution. That is always high concentrated solution to the low concentrated solution. So therefore the potential is developed. That potential may called as concentration potential R. So that concept will be utilized in concentration cells. Concentration cells. Okay. Right. One second. Why we mentioned instead of NF here 2F pins, the number of electrons are varying is 2. The zinc is losing 2 electrons, copper is gaining 2 electrons. That is the N is the 2 only. How many number of electrons are varying? So that is the number N. That's why 2F. Okay. If only in the previous one, chemical cells without transference, only 1 electron is going. That's why RT by F only. But in this case, 2 electrons are going. That's why RT by 2F. Okay. So it's clear? Right. Then concentration cells without transference. Concentration cells means what? The potential is developed due to the transfer of ionic species or any substance from high concentrated solution to low concentrated solution. Keep it in mind. Definitely, we have to take two solutions in the concentration cells. Two concentrated solutions. That may be same electrolyte or different electrolyte. Right? Same electrolyte with different concentrations or different electrolytes. Whatever it. So based on our condition, we have to utilize sometimes the same electrolyte solution with different activities, sometimes different electrolyte solutions. Right. So to construct the concentration cells without transference means with no liquid junction potential, the two electrodes and one electrolyte solution with different activities must be selected. Just see, this is similar to the chemical cells without transference. How many electrodes are there? Two electrodes. How many electrolytes? One electrolyte, right? In the same chemical cells, two electrodes and one electrolyte. Here also two electrodes and one electrolyte. But this one electrolyte must be with different concentrations, right? Same electrolyte with one concentration, the same electrolyte solution with another concentration. So that we have to select, right? So this is the very important how to select electrode and electrolyte solutions. So once we select the electrode and electrolyte solution, one is involved in oxidation, the other is involved in reduction. Therefore, we'll get overall reaction, redox reaction. Just simply apply the Nernst equation to redox reaction. We can get the final equation. This is the phenomena involved in all these four equations, right? The same phenomena for all. How the construction of that particular cell is the important, whether it is having with transference or without transference, right? So based on that, we go through, right? Okay. Here, to construct the concentration cells with no liquid junction potential, two electrodes and one electrolyte with different activities must be selected. So what are that electrode? What are that electrolyte solutions? We'll see. Similar to the chemical cells. Similar to the chemical cells without transference, right? Consider HCl is an electrolyte solution with different activities A1 and A2. HCl electrolyte we are considering with A1 and A2. A1 is the one activity, A2 is the another activity, right? So just wait. Yeah. So coming back, am I audible? Yes, am I audible?
Yes, yes, sir.
Okay, right. So, okay, HCl is the electrolyte solution with different activities A1 and A2, right? So now we are considering one cell with activity A1. The first cell is with activity A1. So what was that cell means, right? This hydrogen gas is dipped in HCl solution whose activity is A1, which is combined with chloride electrode. One electron hydrogen electrode, another is the chloride electrode. Because HCl is an electrolyte solution. HCl is an electrolyte solution. That's why one electrode is the hydrogen, other is the silver chloride by silver electrode. That is a chloride electrode. When these two are combined, hydrogen will be involved in oxidation, then chloride will be involved in reduction. Same equations what we wrote previous chemical cells without transference, right? So what are those means? Once the hydrogen electrode, this is the hydrogen electrode representation. This is the dipped in HCl solution, and also chloride electrode also dipped in HCl solution. Once the hydrogen is undergoing oxidation of H2 gives rise to H plus electron. So means one electron it will be produced, hydrogen electrode. That electron is gained by the silver chloride, is converted to the Ag plus Cl minus. Okay. If we can apply Nernst equation to the individual equations like oxidation means for hydrogen electrode, we can get E of H2 is equals to E naught of H2 minus RT by F ln activity of H plus. Activity of H plus. So then for silver chloride electrode, E of AgCl by Ag. This is the representation means simple, it represents AgCl is converted to the Ag. Okay, right. So these are the two. Then if we consider the overall cell reaction and apply the Nernst equation, we can get one equation, right? So this is the overall cell reaction. Overall cell reaction is what? Half of H2 gas atmosphere plus silver chloride gives rise to silver plus activity of HCl. Now apply Nernst equation to this. E cell is equals to E naught cell minus RT by F ln activity of HCl. Because the product activity of HCl will be there, silver will be there. Silver is the solid. For solids activity is 1. Then silver chloride also solid. For solids activity is 1. Then H2 is the gas. For gases, pressure is the 1. The remaining all becomes 1 except activity of HCl. That's why we will get only activity of HCl. That is E1 is equals to is not cell minus RT by F ln A1 of HCl. That is the equation number 1. This is the equation already we derived in the chemical cells without a transference. Same equation you have to write up to here. Okay. So what we derived the equation in chemical cells without transference. Okay. Like similarly, what we've written equation 1. The entire equation should be repeated with another activity that is A2, right? So now consider the cell with a different activity, that is the A2. Same electrodes, hydrogen electrode and a silver chloride electrode, but the activity was different, A2, right? So in this time, hydrogen and silver will be there. Same, the two are involved in oxidations and reductions. The hydrogen will be involved in oxidation. Silver chloride will be involved in reduction. Therefore, we can write the overall cell reaction and apply EMF, apply Nernst equation. Apply Nernst equation, we can get E2. So first activity A1 30, right? For activity A1, we will get E1. Okay. For activity A2, we'll get E2. By combining of this E1 and E2, we can get the overall solution, what we want, right? So that we have to see in the next slide. Right. Right. This is the E2 equation. E2 is equals to E naught of AgCl by Ag minus RT by F ln activity of HCl. That is the A2. Activity of HCl. So therefore, the overall cell reactions, both are having same reduction potentials. That's why we need to subtract the equation 1 and equation 2. If one is having oxidation, other is having reduction, at that time you have to combine. But both are having same reduction potentials. That's why subtraction. Equation 1, that is the E1. Equation 2, that is the E2. So that we have to subtract, right? So that is E cell is equals to minus RT by F ln activity of HCl minus RT by F ln A2 of HCl. So therefore, this can be simplified RT by F ln A2 by A2 minus RT by F ln A1, because this minus into minus becomes plus. This A2 we have to write first and later A1. Then ln A minus ln B in the form of like that. Therefore, we are doing ln A by B formula. ln A by B formula, that is E cell is equals to RT by 2F ln A2 by A1. Why here we are getting the 2F means, for one cell, one electron is giving with one activity. The another activity also there one more electron will be getting. That's why therefore RT by 2F we are getting 2 electrons, right? So from one electrolyte activity A1, that is 1 electron. From activity A2, that is another electron. So that's why RT by 2F here. Okay. So then as we know the concept of activity coefficients, right? Activity is equals to what? Activity coefficient into molarity. Activity is equals to activity coefficient into molarity. But previously, only one ion will be there. That's why M into gamma. Now, activity of A1 means 2 ions are there. This A1 represents HCl, activity of HCl. Activity of HCl means H plus ions will be there and Cl minus ions are there. The concentration of HCl and the concentration of Cl should be considered. That's why here M1 gamma 1 whole square. M1 gamma 1 into M1 gamma 1. One M1 gamma 1 for H plus ion, another M1 gamma 1 for Cl minus ions. HCl will be there. That's why combining of these. So that will give M1 gamma 1 square and M2 gamma 2 square. Right? These values will be substituted in this equation 3. Therefore, E cell is equals to RT by 2F ln M2 gamma 2 whole square by M1 gamma 1 whole square. So the 2 will come front because ln something x to the power of n means n ln x. The 2 will come 2 to get cancelled, and simplifying we can get that solution, right? So this whole square will be there, right? These two whole squares can be written as whole square of this part, that is m2 gamma 2 by m1 gamma 1. m2 gamma 2 by m1 gamma 1. Right? So therefore, that simplified equation is 2 will come, this 2 will come here, right? So here square is there in the previous slide, that 2 will become here, and 2 to get cancelled, RT by F ln gamma 2 M2 by gamma 1 M1. Therefore, E cell is equals to RT by F ln M2 by M1 into gamma 2 by gamma 1. Therefore, that will be simplifying. E cell is equals to RT by F ln M2 by M1 plus RT by F gamma 2 by gamma 1. So this is the equation is similar to the little bit chemical cells with the transference, right? So because the activity coefficients are considered in the chemical cells with the transference, even the concentration cells without transference also, we have to utilize these equations. Therefore, with the help of this equation, right, this M2 by M1 concentration is known, R is known, T is known, then F also known. By combining of the two cells, we'll get the E cell. By combining of the two cells, we'll get the E cell. Therefore, we can get the activity coefficients ratio. Therefore, finally, the activity coefficients ratio can be determined with the help of this equation. That is concentration cells without transference. Concentration cells without transference, right? So therefore, conclusion was the ratio of activity coefficients can be determined by the substitution of E cell and the ratio of concentrations of the electrolyte solutions in the above equation. Right? So how to construct the concentration cells without transference? Concentration cells without transference means two electrodes, one electrolyte must be selected with different activities A1 and A2. The electrolyte is the HCl. Two electrodes are hydrogen electrode and chloride electrode. That chloride means silver chloride by silver. Okay. So then hydrogen is dipped in HCl solution having activities A1 and which is connected with the silver chloride. We'll get one EMF equation, that is the E1. The same hydrogen electrode is dipped in activity A2 HCl, then combined with silver chloride, we'll get E2. Therefore, the combining of both E1 and E2, we can get total EMF of the cell. That total EMF of the cell represents concentration cells without transference. Means there is no direct transfer of ionic species. There is no direct transfer of ionic species from one electrolyte to another electrolyte. If there is a direct transfer, what will happen? So that is concentration cells with transference. Concentration cells with transference. Okay. Right. Right. Who is messaging like this? Who is using Redmi mobile, Redmi Note 7? Right. Okay. So this concentration cells with the transference topic that will be continued in the next class. Okay. So 10 minutes class is there, but have some disturbance here. Right. Shall I continue this one in the next class?
No issue, sir.
Okay.
Ji, sir. Ji, sir.
Yeah. Then I will share these notes in the Instagram, right? Or else anyone put message personally on WhatsApp, I can share the notes. You have to distribute yourself to the friends. Okay.
Sir, I will request you, sir, on WhatsApp.
Yeah. Definitely, I will send the notes. Okay.
Ji, sir. Thank you, sir.
Yeah, right. And one more thing, one instruction to all of you, you should write the notes. What we are going to discuss, you have to write. So when you write the notes, you will get some doubts. So that we will clarify later. So without writing, just listening, you can't understand the concept, right? So what we discussed, you have to write the notes, definitely, which will be helpful for exam point of view. So while writing the notes, if you are getting any difficulties, that we will discuss in the next class. You have to notice that and you have to mention, we will discuss in the next class. Okay.
Sir.
Right. Yes. Right. Okay. Now I'm going to conclude the class, right? So all of you take your dinner and good night to all. Okay.
Thank you. Good night.
Okay.
Thank you, sir.
Okay. Thank you.